All right, so we're still working away on Unit 910 here, looking at systems that have constant rates of change. And what I wanted to do in this lesson was a couple of examples from boxes F, G, H, and I. They all kind of go together. So we want to look at some examples that involve rate of change, and specifically we want to look at what is called this fixed cost. And what all of these questions in F, G, H, and I have in common is that they are all sort of word problems. We're given a situation which is described in words, and we're expected to fill in a table or make a graph or answer some questions about it. So let's take a look at an example of a kind of a situation we could be looking at here. Henry is a car mechanic. He charges a flat fee of $25 to inspect a car, plus $10 per hour while he's working on it. And they ask us to complete the following table, which shows his hours worked and his earnings, and to make a graph of this, of the relation. So let's start by filling in the table, because after we have the table filled in, then we can move on to doing the graphing. So the first item in the table here, we've got our hours worked. They give us 0, 1, 2, 3, 4, and 5. If he works on it for 0 hours, how much does he charge? Well, he charges this $25 no matter how many hours he works on it. So just to take a look at the car, once you drive it into his shop and he looks at it, he's charging you $25. Okay? If he works for 1 hour on it, he's going to charge you that $25 plus an additional $10 for that hour. So that'll be a total of $35. And each additional hour that he works, we have to add on another $10. So 2 hours will be $45, 3 hours will be $55, 65, 75. So you can see the pattern there. Okay? So now let's make a graph of this relationship here. We've got hours worked and we've got earnings. We have to decide which one should go on our horizontal axis and which one should go on our vertical axis. Well, we ask ourselves, which is our dependent variable and which is our independent variable? Does earnings depend on hours worked, or does hours worked depend on earnings? It makes more sense to say that earnings depends on hours worked. So this is our dependent and this one is our independent. Our independent variable always goes down on the bottom. So we're going to put hours across the bottom, and we're going to put earnings up on the side. And earnings are in dollars here. And then we want to plot these points. We've got 0, 25, so we go over 0, up 25. We've got 135, over to 1, up to 35, 2, 45, 3, 55, 4, and 65, and finally 5 and 75. Now, what kind of a relation do we have here? We can tell just by looking at it. Is this going to be a linear or a nonlinear relationship? Because we can draw a nice straight line through all of these points. So if I get out my straight line drawer, that should go through all of these points here. But it doesn't. So what have I done wrong here? Well, I've plotted my first point incorrectly. It was 0, 25. I plotted it at 0, 15. So that point should have been right up here like this. So now I can adjust my line here so that it actually now goes through all of my points just like that. And I'll take that out. So there's my nice linear relationship. Okay, now develop an equation for this relationship using the letters E and T. I figured out that earnings, which are going to be represented by E, depends on hours worked, which is H. So I want E equals something H plus something else. Well, how did we figure out how much he earned? Well, we said that he earned $10 for each hour. So it was $10 times the number of hours plus that 25 that he had to pay no matter what. Okay? So we've got earnings is 10 times the number of hours plus $25. Part B asks, what is the rate in this problem and what does it mean? Well, rate is just another word for slope. So let's say I wanted to calculate the slope of this line that I've got here. I can use this formula, y2 minus y1, x2 minus x1. And all I have to do is pick 2 points on my graph. So I could pick this first point right here, which I know has coordinates 0, 25. And I could pick the last one, which I know is at 575. And I know that from my table. I'm looking at this point right here and this point right here. So now I just put those values of x and y into my equation. y2 is 75. y1 is 25. x2 is 5. x1 was 0, and I do that subtraction. 75 minus 25 is 50. 5 minus 0 is 5. So my slope, or my rate, is 10. Now, we've seen this number 10 in this question before. Okay? It appears right here in our equation. And if we go back up to the original question, we can see that he charges $10 per hour while working on the car. And that's what the slope represents in this case. It represents how much he charges per hour. So let's say that this is the cost per hour. What is the vertical intercept of this line and what does it mean in this question? Well, the vertical intercept is the point where this thing crosses our vertical axis. So this crosses our vertical axis right here at our point 0, 25, or just the value 25. What does it mean in this question? Well, 25 was how much he charged just to take a look at the car. So this is sometimes called the fixed cost. This is the cost that you pay no matter how many hours he's going to work on this. And it doesn't change throughout the question. So it's the fixed cost, or in this case, it's the amount just to look at the car. So the last question we're asked is to find the cost of a 7.5-hour repair job. Well, we can use our equation to do this. Our equation is E equals 10 times H plus 25. This 7.5 is a number of hours. So hours is 7.5. Let's just sub that into our equation. And then we just need to punch this into our calculator. 10 times 7.5 is 75, plus 25 is 100. So a 7.5-hour repair job costs $75. So, sorry, $100.